Okay, so we're changing chapter today. We're going to light, and we're going to look at a couple of sessions at ray diagrams. And we start with the simplest one, which is ray diagrams involving plane mirrors. Plane means that they are flat, completely flat. They don't have any curves. They're just flat, like this mirror here, the common mirrors, in other words. And if we look at this picture here, what do we see? We have some pottery here, some container, and we see its reflection inside the mirror. It looks as if it's inside the mirror, but of course we know that there's nothing inside or behind the mirror. And I want you to see, I don't know if you have ever noticed, but always the distance between the mirror and the object is exactly the same as the distance between the object, the image of the object and the mirror. These distances, in other words, are equal. And this is the same. I mean, the image stays there at this position. No matter if we stand here or we stand there, we stand further away or at any position around there, as long as if we see the image inside the mirror, inside this frame, the position of the image does not change. It's always the same. So this is quite important to begin with when we try to draw ray diagrams to show the image formation. So let us begin straight away now with the law of reflection, because the reflection by plane mirrors rely on the law of reflection of light. And here we have it in summary, the law of reflection. If we have, let's say that this is a mirror, a flat, very flat surface. If the surface is very flat, it's actually behaves like a mirror. So this is a flat or plane surface, a flat, smooth, completely smooth surface. And we have, say that this is the ray that falls on this surface at this point. This is the incident ray. You see with this arrow represents the direction of propagation of the light. We represent the light with those rays. So a light ray is actually a ray that we draw. We draw a straight line because we assume that light propagates in straight lines, and this is a ray that shows the direction of its propagation, and we show the direction with an arrow. It's important to use the arrows to show the direction of propagation of light. So when this incident ray, we call it incident because it falls on this surface. What happens when the ray, when light meets the surface, it reflects. It reflects, and this ray here that we draw shows the reflected ray, the direction of the reflected ray. And we notice, I mean, we know from experience, from many measurements, that always the angle of incidence is equal to the angle of reflection. Now, this is the reflected ray. Now look, we need to pay extra attention to what we mean by angle of incidence and angle of reflection. And look at this. This is the angle of incidence. This is the angle that forms between the ray and a line, a normal to the surface that we draw, normal to this surface, in other words, perpendicular to this surface. So this is it's not a ray, it's a line that we draw this with this normal. We call it normal because it's perpendicular to this surface. And then the incident angle is the angle that forms between this normal and the ray, the incident ray, whereas the angle of reflection is the angle between this normal again and the reflected ray. So don't make the mistake to think that the angle of incidence or reflection is the angle between the rays and the surface. It's not the surface, it's between the rays and the normal line to the surface. So this is the angle of incidence and the angle of reflection. And these two are exactly equal. This is the law of reflection of light. There is another extra point that we need to make here is that the incident ray and the reflected ray and this normal belong to the same, lie on the same plane which is vertical to this surface here. Okay, So the law of reflection says that the angle of reflection equals the angle of incidence. These two angles are equal, and that the incident ray and the reflected ray and the normal to the surface lie in the same plane. I hope you remember from geometry what is the plane, okay? So these three lines lie on the same plane. In fact, if in other words, if we put a piece of paper here, they all lie on the same piece of paper. And another important thing that we need to say here before we start with the ray diagrams for mirrors is that for us now to see this ray, we have to have our eye, and the observer must be, when we say the observer in optics, we just draw something like an eye, and this represents the position of the observer, the one that observes the light. So if the observer is here with this ray going through to the eye of the observer, then this observer will see this light. Will see this light, this beam. If the eye is somewhere else, if the observer is somewhere here, for example, this observer cannot see this ray, cannot see anything, any light. Okay, so for us to see this light, our eye has to be in the path of the beam that comes to our eye. And when we draw it, it has to be in the path of this ray that we draw. So that is why here, to make this point more vivid, because it's a very important point. Here we have a beam of light shown from a torch, for example, falling on this flat surface, which is a mirror. And because this is such a flat surface, all these light rays will be reflected from in a way that they reflect, all the reflected rays are parallel to one another. So look at this. It shows observers at different positions at A, B, and C. Only observer B will see this beam of light, this selection of rays here that we have drawn. Only B, because only for this observer, these rays come through his or her eyes. The observer A will see nothing, and observer C will see also nothing. So if you know from experience, if you shine a torch or a laser pointer, which are very common, if you look at this at the beam from the side, if the air is clear and there's no dust, you are not going to see anything. You're only going to see where the torch shines on a wall, for example. You will see a big round circle on a wall or some object, because when the light arrives at this object, it reflects in all different directions, and you receive rays reflected from these objects. But the actual ray, the actual beam of light that the torch emits, you will not see it if you see it from the side. You have to be, your eyes have to be in the path of the light, in the path of the beam to see the light. Okay. So now that we have the basics of the reflection, let us start drawing. Let us discuss actually how to draw, how to begin with drawing ray diagrams for flat mirrors. And by the way, if you need to send a message, you can send me, because I can see here your message here. What do we have here? It's actually, here we have some properties of the images formed by mirrors. Why not? Let's discuss them, since we have them in this page. Look at this, there is a baby here holding in front of a mirror. I hope you can see, this is the mirror, okay. So this is the image, this is the object, all right. So the image, now let us discuss these properties of images. An image formed by a plane mirror is virtual. Virtual means that it's not real, it means it's unreal. It's not a real image, which means if there's nothing behind the mirror, if we put a piece of paper behind the mirror where we think we see the image, there will be nothing in the mirror. Or if we put a photograph a photographic film behind the mirror at the position where we think that the image forms, there will be nothing in the film. So this image does not exist. It's not a real image, and we call it virtual. Okay. It cannot be captured on paper or film placed at that location. Okay. The image is laterally inverted. Laterally means that you see, this is the right ear of the baby. The right ear seems to be here, the left ear of the image. So the image, in other words, is inverted from left to right. This means that it's laterally inverted, and that is why, if you have seen this ambulances, the ambulance is written in a very funny way, because why is it? It is written laterally inverted because a driver that drives in a car, here's the car, and here is an ambulance, and it's written here ambulance. This driver will see in its mirror, the rear view mirror will see the word ambulance, and will see it laterally inverted, and will read it properly as ambulance, to know that there's an ambulance, to get out of the way. So laterally inverted means inverted left to right. It has the same size, very important, and it is upright. You see, it's upright, and it has the same size as the baby. And it appears at an equal distance from the mirror. The distance between mirror and object is the same as the distance between mirror and image. So these two, upright and equal distance, are 2 points that we're going to use when we draw a ray diagram. And here is an example of a ray diagram that we draw. And we're going to see how we get to this ray diagram now. In fact, let us start from this kind of problem. It's the same diagram that we had before, and here it's how to begin to draw it. Let us see how we begin. So this is our object, say it's a candle which is lit. Here's the fire. How do we start drawing an array diagram to show how the image is formed and why we see it? It's quite difficult to start if we don't know the tricks of the trade. And what do we do? First thing is that we rely on the fact that the image is at equal distances from the mirror. The distance between object and mirror is equal as the distance between mirror and image. Equal distances between object, mirror, and mirror. What is this? Image. I forgot the word. So this is an important thing. So what we do first, in other words, we start by drawing the image. That will help us a lot, drawing the rays. So we start by drawing the image. So the distance between object and mirror must be equal to this distance between mirror and object. So, and it has the same size, and the image has the same size. So these two things that we start. So this distance first, we draw now the image to be the same size. I hope I can do it to be the same size here. There is the image. So we start by drawing the image, okay. Same size, that means exactly the same size, same distance from the mirror, all right. Now so first thing, draw the image following these guidelines. Okay, now we have the image. Why do we see the, say that the observer is in this position, okay. The observer could be anywhere, as long as we have an eye to begin with. Put the observer somewhere. So this observer now, if this observer sees the image, it's because he or she receives rays that seem to come from the image. So look at this. We just need to draw two rays that reach the eye that seem to come from the top and from the bottom of the image. So let's see. Say that this observer here thinks that there is a ray coming. Obviously, if this observer sees the bottom of the candle, is because receives a ray that seems to come from the bottom of the candle. And also if this observer sees the top of the flame, is because he thinks that there is a ray coming from the top of the flame. Of course, if we draw it on a piece of paper, we use a ruler because I'll try to draw straight lines. So I draw dotted lines here because this is what we think that we receive. Now, of course, we know that the mirror is a opaque object. The rays cannot go through this mirror. So we know that it is not possible that these rays are real, okay? But nevertheless, we draw these lines first. Now, in front of the mirror, there can be light here. So these lines in front of the mirror, I can draw them like solid lines because these have to be real rays received by our eyes. And this one, up to the mirror, I can draw them as solid. Solid lines will represent like real rays that our eye receives. And because our eye receives those rays, remember to use the arrows to show that this is the path of the rays entering our eyes. Now, okay, up to here, okay, that's fine. Where does this ray come from? Let's start from the top ray. Where does this ray come from? Well, our eye thinks, or our brain thinks, that it comes from the top of the flame. But of course, no, it does not come from there. It comes from the top of the real flame. So this ray actually is a ray that has come from traveled from the top of the flame, fell at this point in the mirror, and then it was reflected towards our eye. So this ray, be careful, comes from the top of the flame, and this is now a real, when I say real ray, I mean a real beam of light coming from the top. Rays are, strictly speaking, the lines that we draw. Okay, so there we have the first ray of light. From the top of the flame, it fell on the mirror and it was reflected, following, of course, the law of reflection. Of course, here, if we draw the normal to the mirror, the angle of incidence is equal to the angle of reflection. I mean, the law of reflection applies to all the reflections on the mirror that we're going to discuss. So anyway, so this is the one ray from the top of the flame. Now let's see the other one from the bottom of the candle here, the bottom of the image that we think comes from the bottom of the image. This line here came from the mirror after reflection, and which ray was reflected to end up here to our eye is obviously the ray that came from the bottom of the real candle. So this is the real light that fell on the mirror in this direction and was reflected by the mirror. Follow the law of reflection again. Angle of incidence equal to the angle of reflection. And this ray, once it fell on the mirror and hit the mirror, it was reflected towards our eye. So this is the ray diagram here. Obviously, it's a lot clearer. That corresponds to the formation of this image of the candle that we see behind the mirror. Obviously, in between the object, there are millions of other rays that we could draw that fall on the mirror and they're reflected and reflect towards our eye. But I mean, we don't want to draw millions of rays here because it will be very confusing. As long as we have a ray that comes from the top of the object and a ray that comes from the bottom of the object, that's enough to show why we see the bottom and the top of the candle of the object in the mirror as an image. And of course, any other ray from the middle of the object would follow the same story. I mean, let's say one ray from there, for example, that corresponds to this point at the image. Our eye would think that there is let's draw it in a different color. Let's draw it blue. Okay, where's the blue? Yeah. Say this position of the object. our eye would think that it receives a ray from this position, isn't it? From this point of the object. This ray would be the real ray, the real light getting into our eye. And this ray, of course, this real ray, is a ray that has been reflected from the corresponding point on the real object, like that. So I could draw rays from any point of the object in between the bottom and the top, okay? And I would follow the same procedure, but it's not necessary. As long as we have a ray from the bottom of the object and a ray from the top to show the top and the bottom of the image formed, that's enough. So this is enough. In other words, these two rays from the bottom and the top are enough to show why the image forms behind the mirror at this position. Okay, so this is how we draw a ray diagram for a flat mirror. Remember, we draw the image at the same distance behind the mirror as the distance of the object in front of the mirror, and also of the same size. And once we have the image, picture of the image, then it helps us to draw the rays that get into our eyes, okay? The rays in front of the mirror are real rays. The rays behind the mirror are not real, they are virtual. That's why they are dotted. But these rays, now the real rays, help us to see where the rays from the object, from the actual object, the corresponding point of the object have fallen on the mirror and have been reflected. And this trick, we do it just to help us draw the diagram, the ray diagram of from a mirror, okay? Of course, we would do the same if the observer was at a different position, okay? There's no need for the observer to be there. The observer could be there, or could be there, could be in different positions around the mirror. Every time we draw rays from the image to the eye to find out where the other rays, how they have come and where they have been reflected from, and so on, okay? We see here the flames are projected wrongly in the images, aren't they? Yes, they are, of course. It should be laterally inverted, but it doesn't matter as long as we have the top of the flame and the bottom of the object. Yes, don't worry about it. Don't try to draw art. In fact, when we draw an object in front of the mirror, we don't have to show its real shape, okay? Sometimes in the books we draw little candles and little people just to make it more interesting, but in reality we could draw an object just like an arrow where this shows the top of the object and here shows the bottom of the object. There's no need to do art here, okay, even if we are artists. So strictly speaking, we could have, instead of a candle, we could have an arrow here, and here the image would be an arrow again. Okay. All right. I hope that the main points here are understood. Is there any problem here? I mean, the idea is to draw a couple more examples. Yeah, let's do this problem. Okay, here we have a mirror, and here we have an object shown by an arrow, so we don't have to worry about laterally inverted images. And here's the observer. So it looks like a very different case than before, because the observer is in a weird place, and the arrow is not even vertical, parallel to the mirror. What do? We start as we did before. First, we draw the image. We have, let's draw, remember that the distance from the mirror must be the same. This distance must be the same as this distance in front of the mirror. So, goodness, now my drawing. Okay, so this will be the bottom of the object. I hope this distance is equal to this distance, okay? Then the top, let's also draw the top. Even if it's outside the mirror, it doesn't matter. As long as this distance, okay, as long as this distance is equal to this distance, okay, let's hope something like that, eh? Don't accuse me if I don't draw very straight lines, because it's not easy to draw with this pen. Okay, so this will be the image now, the virtual image. Okay, great. Now we have the eye. Now, if the eye sees this image, it's because the colors, throw different colors. Hello. Okay. So our eye will receive, obviously, we'll think it receives one from the top of the object and another ray from the bottom of the object to enter our eye. These parts are the real rays that enter our eye. There's the direction of the arrows. Yeah? Okay. Okay, there is another arrow entering our eye. These are the real ones, the real rays. Now, this ray here, which we think comes from the bottom of the image, our brain interprets the information like that, actually comes from the bottom of this, the real object. So this is this ray, yeah? This ray that left the object and fell in the mirror and was reflected and into our eyes. Now the other, oh goodness, it gets too small. Let's make it a bit bigger. When it's very small, it's not easy to draw better. All right, so, oh dear, look at this scribbling. All right, so this ray now, the one that we think comes from the top of the object actually comes from, the one that we think comes from the top of the image. It's actually the one that comes from the top of the object. And so this ray fell from this top, this mirror, and it was reflected and into our eye. And so this is the ray diagram of this object. By the way, look at these rays here. These rays are virtual, they're not real rays. And that is why this object, the form that forms behind the mirror, that we think forms behind the mirror, is actually a virtual object. It's formed by virtual rays. This is not real light here behind the mirror. That's why this is a virtual image. Because we're going to see in other cases, like through lenses, images formed by real rays, and that is why these images can be real. So that is why it's important to say this is a virtual image and this is a virtual ray. So it's important to know that. By the way, why do we think that the object is behind the mirror? Because our brain receives those two rays, and our brain does not know the history of those rays, does not know if these rays have turned left and right and bounced here and there. Our brain thinks that those rays travel in straight lines, and that is why we think that the image is formed behind the mirror. It's just a perception of our brain, simply because we cannot tell the story of the rays have been gone through. They're even more, I mean, I don't know if you have seen, I have put some lessons now that we are revamping the site, you know, and I think that, yes, not I think I remember, this is from the lesson. I took this picture from the lesson, and there are some explanations and some worked examples. I hope you understand there what's going on if you look at them, if you ever go to study this light, this chapter. But guys, if you have any problems ever, you can always ask me, and you can also suggest topics to do in the live lessons, because I don't want to do a little bit of here and a little bit of there. I want to get the topic and stick to it to make sense, to understand the topic, to certain concepts which are important. It doesn't worth going to a topic, to a chapter, and have a summary. What to do with a summary? The idea is to understand a few things deeper than, I mean, it's better to understand 3 things better than doing 10 things very superficially, I think, for your exams. And that is why, because you can also suggest topics that you need. I think that, in fact, after ray diagrams, we'll do refraction and lenses. And after that, I think we can go to electric circuits, where there are more calculations, I suppose, and there are some difficulties. All right. So, oh dear, we need to stop now. Guys, I hope these things make sense, and suggest and ask if you have problems. All right. So I hope you will enjoy your weekend, guys, and all the best. Right, be good as always. Always good, I know. So let's call it a day because it's 12 o'clock. Bye.